Good afternoon and welcome to Graphing Logarithmic Inequalities. Go ahead and take a look at the warm-up really quick. Make sure to take a look at the domain restrictions for part A, B, and C before clicking to the next page to reveal the answers and make sure that you actually have the correct answers. But I will give you a few minutes, so go ahead and pause the video before doing so. Alright, make sure on all of these you feel comfortable with domain restrictions both for your final and for this next couple of units. Notice on that first one we do have an odd root. I'm going to go and make a little note of that. So the nice thing is if it is an odd root, you should have an all real number. So there should be no domain restriction whatsoever. You can choose anything. Cube root of anything is still anything. We love those problems because there's no thinking whatsoever. The next one are your rationals, which we haven't seen in a while, but still good to look at. Again, denominator cannot equal to 0. Again, if it does, unhappy things happen, black holes will happen. So just make sure to set whatever is in the bottom denominator not equal to 0. Solve, like I trust you know how. Set or interval notation is completely fine with me. So on the first one, we can just say x cannot equal plus or minus 3. I don't recommend interval. It gets too complicated. The last one are your logs, the new stuff. So again, arguments inside of a log, again, never argue with a negative person. So whatever is inside must be positive. So just set whatever the argument is, in this case, 2x minus 10, greater than 0, not equal to. Be really careful with that extra restriction. Again, copy paste right into set. So everything bigger than 5. Or again, if you'd like to use interval, parenthesis 5 to infinity, whichever you would like to do better. Jot those answers. I will come around and stamp your warm-up later. So our main focus is going to be graphing exponential logs and inequalities, how to find all the solutions. On these first couple of examples, I've already graphed them for you just to save on time. Obviously, you will be using your graphing calculator. So head on over to y1 and y2, plug in everything that you already have. So on the first example, go ahead and plug in 1/3 2 raised to the x plus 3 everything minus 7. Your job is to look for where it is above 0, anything greater than 0. So our main focus is going to be anything above this red line. So anything above here are all of the good solutions. Again, the nice thing about exponentials is we have no restrictions. The exponent can be any x value whatsoever. We just get a free-for-all. However, what we do need is this spot right here, that intersection. Again, since these are all calculator based, head over to your calculator, hit second, trace, happy place, option 5. Intersect, hit enter 1, 2, 3 before getting there. I'm going to go ahead and click and drag that so you can see where I got that number from. So from there. Again, you can always click on your table, get a couple little points just to make sure you actually have the correct answer. So instead of writing it over again because I'm too lazy, you can see the table right here on my calculator. Again, everything that you need, you want to make sure that the first one, y1, is bigger than y2. So in this case, I made y1, that blue part, I put a little blue dot there, and y2, the red dot. So that's my red graph. So everything, compare all of those, bigger than 0, bigger than 0, bigger than 0. Gets kind of crazy after a while. Do some good testing. So on those first couple of numbers, negative 4.3, not bigger than 0, not bigger. 3.6 is bigger than 0. 14 is bigger than 0. All of these in green that I've highlighted, all true solutions, everything that counts. Everything below, not so good. But that's okay, we don't even need them. Please remember, all of these right here, think of them like test values. They're there to show you whether they work or not. Your main focus are the x values. You are solving for x. Please keep that in mind every single time you do this. So on here, you can have everything from this point onward. So at that point, we've got x is 1.39. So for us, not equal. Jot a little note to yourself just in case you need to. So in this case, parenthesis at 1.39, and head on up to infinity. All the x's after that are in clear, and we are good to go. That's how fast they go. Nothing to think about. Next one's a lot friendlier. Again, I've already graphed it just to save the time for you. Again, everything less than or equal to 5. So your job, everything below 5. Everything below that 5 line. So anything here is what we are allowed to have. Again, the rest of it you're going to want to use your calculator for, because let's make it go faster. Why not? So go ahead and use your graphing calculator to help you figure out this intersection point right there. There it is, purple arrow, so you can see it nice and bright. Head over to Y1, plug everything in, so again, you don't have to do it by hand. You're welcome! It is on calculator. So your calculator should look like that, Y1, Y2. Hit the graph button so you can make sure you can see it. Again, if you cannot see it, you cannot trace it. Second, trace, happy place. Option numero 5, intersect. Hit enter 3 times just to make sure you've got it. Again, on all of these, I'm definitely okay if you go ahead and round. That's what we're going to have to do on these first couple of examples. So 2.46, y is 5. Again, you're solving for x. So in this case, I can have all the x's. Again, if you want to put a little arrow just to help you see it a little bit better. Final solution set, negative infinity. So all those negative numbers below 5 stop at 2.46. Bracket. You can include that. You're allowed to be equal to, so don't forget that final step. Again, if you'd like to go ahead and use your table just to help you see it a little bit better, of course you may do so. I'm going to go ahead and bring that over here so you can see what I'm trying to do. So on here, again, your job, y1, in this case, less than or equal to y2. Again, the blue part I've made as my exponential. The red part is that graph. So again, I'm going to use the green part, show you all the good solutions. So 0.33 less than 5, not so much. 1 not less than 5. But right here is good. 9 is less than 5. 27 less than 5. All these right here. Good test values, good solutions. All these in pink are the not so good ones. So all the good solutions you need are probably around here. So x could be 3, 4, even somewhere between 2 and 3. So these are all of the happy ones. Put a little smiley face. Exponentials, very easy, very fast. Another one that you could probably see are these, the ones where you're given a table. The nice thing about the table is all you have to do is give me, you've guessed it, an approximate solution. Please do not make these harder than they actually are. These are all predictions, guesses, what you think. So on this one, I've already made the table for you. Congratulations, I've done the work. So this part is y1 in blue. So again, I'm going to color code that so you can kind of see which one is which. This 8 to the 3p, I put into y2 right here. Again, all those y values are the test values. That's what you're going to make sure actually will work. Plug in, you want to make sure that this is what is true. So go ahead, if you need to, you can put that symbol on there, greater than or equal to, all the way through, just to help you see it a little bit better. So working up, 81, bigger than that hideousness, not true. 27, definitely not bigger than 512. But 9 is bigger than 1. 3 is bigger than 0.001, is bigger than that decimal to the whatever power. All those in green are the good ones. Again, 27, not bigger than this. So all the ones in pink are the bad solutions. Can't have them. So again, you're choosing p, or in this case, x value. So anything from, it looks like negative infinity. And we kind of get stuck right here between 0 and 1. This is kind of the spot I really want you to focus on. This spot right there. So you can kind of see where you've got the good solutions mixed in the bad ones. So somewhere between 0 and 1, there's a shift. But again, I don't expect you to know exactly where that is, which is why you have your favorite word in the world, approximate. Means you can guess. Fancy word for guess. So you can have all the numbers below there. Easiest number between negative 1, 0. Again, please estimate. So between 0 and 1 right there, so about 0.5. Again, you could say 0.75. I'm really not going to be too picky. But since you can be equal to, make sure you do bracket whatever number that you are guessing. So just be really careful there. Again, approximation, very easy. Please don't make those harder than they are. Again, put a little smiley face next to these. We love these problems because I'm doing the work for you. You just have to make sure that you understand the work. The next couple are by far probably the trickier ones because you've guessed it, we're going to build some cabins. We're dealing with logs. Again, I've already done the graphing for you because I love you. You may use your graphing calculator to do so. If you'd like to check, head over to y equals. Again, if we're putting in logs with different bases, hit the alpha button, hit F2 where it says window. Your job you need is option number 5, log base. Helps you change things. Plug in everything that you have. So you got a base of 4, and we're going to plug in 10x plus 1, alpha, F2 or window, option number 5. Again, here, look at those buttons in red to help guide you just in case you need to know. Base of 5, we want 16 plus 6x. I'm going to go ahead and leave it like that for now. Tricky thing, just like on the warm-up, logs, again, never argue with a negative person. So the arguments for logs can never be negative. No, no, no. Be very, very careful. So they do have restrictions. These are going to be different than all of those exponentials. So again, anything in green that I've highlighted, so this 10x plus 1, bigger than 0, always positive. So for the first one, I've got x is bigger than negative 1/10. We can do the same thing on the other one. Solve, 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 solve. Again, only the part that's in the argument. Make sure whatever it is, bigger than 0. Do not equal to. No so good. So you got two different options. We got x is bigger than negative 1/10 or x is bigger than negative 16 over 6. No, you don't have to simplify. The correct response is you're welcome. The key with all of these, just like it was before, choose the most restricted. Again, fancy math words for give me the least options. Whichever one of those gives you the least. So I've got x is bigger than negative 1/10. X is bigger than negative 16 over 6. Least amount of options. So sorry. This is the one we're going to use. Which, you're welcome, I've already graphed for you. It is right there. It's that vertical asymptote. It's where that is. So for this particular example, again, I've already done the graphing for you. So log 4, this is your y1. For my graph, it's the one in blue. Right now. Log with the base of 5, I went ahead and put into y2, which is the one in red that I've already graphed for you. Your job for this one, to check for solutions, you want y2 bigger than y1. If that's kind of what helps, you want everything bigger than that. So you can even look at that. I'll go ahead and flip over, head on over to your graph so you can go ahead and do a really, really quick sketch. So on all of these, you want everything below y2. So all the highlighted pieces are going to go right here. All of these are the goodies. All the happiness are in this yellow region. You can put smiley faces to help you. All of these are good solutions. All these x's. Look how many options you have. So why we like inequalities. You can have as many options as you want. Anything below the red line. And again, you need to make sure you use your calculator, figure out what this intersection is. This tiny little spot right there. Figure out where that is. Intersection. Every single time. It matters. So, second trace, happy place. Option number 5, intersect. Enter 3 times. Oh, and look at that. I must love you because the intersection is super, super friendly. It is at 1.5, easy decimal, and again, 2. Final solution set. It's very hard to see, but it's going to be all those x's right in that purple region. So most restrictive, so your final solution set, use that asymptote. Do not touch it, so parentheses around that. Negative 1/10, comma, up to 1.5, comma, parentheses. Be really careful there. So 1.5, you cannot equal. Right here, cannot equal. Logs are going to be the trickier ones, so let's go ahead and try another example really fast. Again, I've already done the graphing for you. To save yourself some time, you're welcome. Use your calculator. Check those domain instructions. Anything in the argument, again, can never be negative. Do not argue with someone like that. So on the first one, x must be bigger than 5/3. Second one, x is bigger than -7. If it helps, you're trying to pick something that works for both of them, which is why you need that most restricted. Those words that I wrote right here in purple, most restricted. That's your job. So do the same thing here, most restricted, what gives you the least amount of options to work with, and you're going to start there. Bigger than 5/3, bigger than -7. This is the one we're going to work with. And again, already graphed for you because I love you. This one's going to be a little bit different. So again, I've already put into y1, and I've already done y2 right here. So on this next one's going to be a little bit different because you want to know where y1 is above y2. So you need everything above y1. It's going to be a little bit hard to see. So all this stuff right here, it's going to be really hard to see on this graph. But again, before you do anything, get this intersection spot. That spot right there. So head on over to y equals, put those points in there. So this one has a base of 3. And then your argument, you're going to have 3x minus 1. I'm sorry, minus 5. That was the last example. This one, again, I must love you because I made the bases the same. Plug everything in as is. Don't make this more complicated than it needs to be. So in here, we're going to do x plus 7. It's the only thing that we have to worry about. Not bad. So those are your two pieces. Go ahead and hit that graph button. Please make sure you can see those points. If you can't see them, they do not count. Not too bad. Second trace, happy place, option 5. Intersect, enter 1, 2, 3. Please make sure you can actually see the blinking light, so go ahead and fix it if you need to. Oh, and I must love you more because your intersection is x equals 6. How lovely is that? You're welcome. So on this one, you want this spot right here all the way to infinity. So this is kind of where your solution set's going to be. So on this one, you don't even need the domain restrictions. Not even necessary. Who would have thought? So for this particular example, you just want to have everything bigger than 6. Or if you'd rather, you can even do your favorite interval notation if you're a fan of sideways 8s. Infinity. Bracket, because you can be equal to on this one. So equal to. So I'm going to put that part in red right there so you can see that. Not too bad. The logarithms will be the trickiest, but we will spend some time and we'll go through them, and we'll take another day on it. So this is just the first day. Still not too terrible, though. So I'm going to go ahead and show you an application of these, experimenting with different sodas, using them internets to find hydrogen ion concentrations, pH. I know you've seen this already in chemistry. Who would have thought it would have trailed into Algebra 2? I went ahead and showed you a pH chart showing of different sodas. So on each of these part of these questions, it's showing you that the hydrogen ion concentration in a random soda, in this particular case, is 0.003 moles per liter. Our job is to actually identify it. So you've guessed it. You actually just get to plug in. No, I'm not kidding. It is that easy. Literally, plug in 0.003 for the hydrogen mole concentration. Please use your calculator. No, you don't have to do this by hand. So negative log 0.003. Yep, it's that easy. So for this first one, I'm going to have a pH value of 2.52, which is lovely because it matches up with one of my personal favorites right here, Coca-Cola, pH value of 2.52. So that's all you have to say. So letter A, the random soda that we're actually looking for is Coke. A cola. Next one, you're going to do exactly the same thing, literally. Plug in the moles. This one I'm making you work a little bit more because I added some extra zeros for your enjoyment. 0.000, however many I've got, 575. Please, don't make these hard. Plug them in. Negative log, you've guessed it, 0.00004 zeros, 575. That easy. pH value of 4.24, which takes us to my ultimate favorite soda, root beer. pH value 4.74. Good old science joke. Somebody asks what your favorite soda is, say it has a pH value of 4.74. They look at you like you're goofy, but at least it's an inside joke. So this one happens to be root beer. Root beer. I think you got the hang of it. I'm going to go ahead and let you figure out part C on your own. You got this. Last question I'm going to show you is another application dealing with gardening. I thought this one was rather interesting, and I was really excited to share it with you. So the flower color for big leaf hydrangeas. Big thing about these is they all come from the exact same seed. What matters is the pH in the soil. It severely affects the kind of flower that you have. So if the soil has a pH value of between 5 and 5.5, your flowers are going to come out blue. If your hydrangeas come out purple, they're going to have their soil had between 5.5 to 6 pH value. And if you have pretty little pink flowers, the pH in your soil is between 6 to 6.5. Even though they're the same seed, the color depends on whatever your soil is. So soil has just as much to do as the seeds do. So because I measured my hydrogen concentration in my soil because I'm a fantastic gardener, you have this number of moles per liter. Again, lots of zeros. Why? Because I trust you can plug it in. Well, most of you I trust can plug it in. So, like I said, plug it in. Don't make it too hard. You're going to need this color chart for your homework, so make sure you can clearly see which one is blue, purple, and pink. So 0.000, oh my goodness, 1, 2, 3, 4, 5, 6 zeros. My goodness. The horror. 6 whole zeros in your calculator. But yes, go ahead and plug them in. Just be super careful. So negative log point. Oh my goodness. 1, 2, 3, 4, 5, 6. Plug it in. All right. So it looks like for this particular example, I have a pH value of 0.66 or 0.22. Go ahead and match that to 1 on your chart. This one happens to be pink hydrangeas. So is the soil good for growing pink flowers? If not, which flower would be best? This one, it is good for growing pink because this particular value happens to be between the 6 and 6.5. That's how fast it goes. But again, please use this color chart for your homework. You're going to need it. It's really going to help you. Speaking of which, your favorite word in the world, homework. Although my favorite word, practice. Please take a look at this. I have textbooks in the back of the room to help guide you in class just in case you would like to see more colorful examples. Please look at page 522 in the textbook at the back of the room if you do need an extra resource. If you'd like to go through this video again, there will be laptops in my room that you may also use. Please return the laptops as soon as you are finished. Make sure that they are charging by the time I get back, and they are all pretty in their case. Thank you for watching, and again, please work together. Turn in the homework assignment you received Thursday to the sub at the end of class on Monday. Let me know if you have any questions. Email me, tweet me. Please do not be afraid to do so. Hope you guys have a great night and or morning, depending when you're watching this, and I will see you Tuesday.